The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone. My name is Hayden Frank. I'm a lead meteorologist with the National Weather Service in Boston, Norton. And tonight's webinar is going to be on the January 25th, 26th snow bust from a few weeks ago. Just a few more things. We do have another webinar coming up on Tuesday, March 14th at 7 p.m. That's going to be remembering the March superstorm of 1993. Those of you who lived up in New England or anywhere across the eastern United States may remember that one. That was a pretty a big event for a lot of folks. So before we get started tonight, use the chat boxes for any questions you might have. It's just myself tonight, so I will try to answer as many of them as I can get to at the end. And also, all webinars are recorded and will be posted on the National Weather Service Boston YouTube video page. And please join our notification list for new webinars. You can email Joseph Delacarpini at noaa.gov. He is our Science and Operations Officer. And also, if you go to weather.gov/Boston/webinars, we'll have the latest schedule for those upcoming webinars. And again, the next one is scheduled for Tuesday, March 14th. So with that, we will march ahead here. And taking a look at what happened, again, this event was a few weeks ago. We had a coastal low pressure system that brought a bit of snow, not much. It was basically a coating to up to 2 inches, and that was mainly north and west of the Worcester area. Snowfall forecasts were overdone across southern New England, especially across the interior where a front-end thump of snow was expected. That's what we usually consider a burst of snow. May come down quite heavily for 3 to 4 hours. It's short-lived, but can often be quite a snow dump, but did not materialize in this case. And there was some heavy rainfall, some minor river flooding, and some wind forecasts, which were handled better than the snow forecast. So bear with me here. Having a little trouble advancing the slide here. Okay, so let's take a look at the radar loop. This was roughly from 1 in the afternoon Wednesday through 7 in the morning Thursday. And what you'll notice, there was an initial band of snow that was associated with the warm advection. It moved through the region faster than expected, and there was also a lot of dry air that got involved. As you can see, the precipitation was somewhat fragmented on radar. That's never a good sign. Where you start to see the solid greens and yellows, that was already rainfall by that time. So we had kind of a small window where temperatures were going to be cold enough to support snow, and so much dry air got involved that limited any accumulations. Again, there wasn't much east of Worcester and northwest of Worcester. Again, generally we're looking just a coating to perhaps an inch or two. So another way to look at this is the mid-level water vapor loop. And what you'll see here is you start to see the darker cloud tops. Those are the higher cloud tops. That's where you're looking at more organized, heavier precipitation. Notice that's at the kind of the back end of the event when temperatures were warm enough to support rain. But initially, everything's somewhat fragmented, and that's an indication of that dry air that came into play and pretty much prevented much snowfall from occurring on the front end of this storm. Again, it was always supposed to change to rain. It was basically looking at a 2 to 6 inch event, and instead it ended up being a coating to just 2 inches. And again, that was for the distant interior. So you might be wondering, what do we actually look for when we're looking for a front end thump of snow? Now, these aren't usually our nor'easters where you get that low going to the east of us. You may be expecting 10, 15, 20 inches in a real big one. These are usually less, but they can be quite potent for, say, 3 or 4 hours. You could get, 1 to 2 inch per hour snowfall. You could get, a quick 5, 7, 8, 9 inches of snow. So usually we're going to have a 700 millibar low passing to our west. And that's what happened in this case. However, in this case, it passed so far to the west that it kind of left us to the east of the better dynamics. You see this dark purple shading. That's where we had really strong winds at 700 millibars. That's roughly 10,000 feet in the atmosphere. So that's where you had your strongest forcing, was to the west of our area with that initial precipitation. Another thing we really look at is, say, what we call thermal gradient, temperature gradient. We may be used to seeing something like that. Today we had, temperatures actually pushed 70 degrees across parts of Rhode Island and Southeast Mass. It was a bit cooler in the north, obviously still well above normal. But when you see that tight gradient there, you can see it over the Buffalo area. The atmosphere is always trying to stay balanced, and it does that by, advecting wind in a certain direction based on, thermal gradients across the globe. And in this case, well, this is where you're going to likely have your strongest forcing, where that thermal gradient is the tightest. Okay, the atmosphere is trying to balance itself out. If you look east, this is right around 1 o'clock that afternoon when we're supposed to start getting into the snow. You don't see that tight buildup in those thermal profiles too well, and that's an indication that forcing was too far west. And you can look at different parameters. This is from our one of our computer models, the RGEM. It's the regional Canadian model. And look, here is 700 temperatures overlaid with frontogenesis. The temperatures are in the dashed lines here, and the frontogenesis is in that area as well, where you see that I say white shading. That's where your strongest frontogenesis is, and it usually coincides with where you have the tightest thermal gradient, and you see it here to our west. And it's more fragmented in our area, so it really makes sense how this unfolded. Looking at our HREF model, this is 850 millibars. And I should mention, if you've been on these webinars before, we do show the HREF quite a bit. It's basically a short-range ensemble. When we say ensemble, putting a bunch of models, in this case high-resolution models, together and kind of coming up with a consensus. So kind of, what's the worst case scenario, what's the best case scenario, kind of blends that too. And getting a consensus forecast can often be the best. Not always, but it can lead you in the right direction. So we looked at 700 millibars. Now we're looking a little higher up at, say, 850. So we're about 5,000 feet off the ground. And a couple of things to note. You usually have your best lift and forcing and moisture with a south-southeast wind across New York. Further east, you notice the winds are not as strong, so you do not have as much forcing in our area. And also, they're more of a south or even hinting in a southwest direction. So that's less favorable for a front-end thump. Back those winds more to the south-southeast, and especially if they're at higher speeds, your chances of getting a front-end thump of heavy snow is greater. And you can see here, you had 60 to 70 knots of wind, 5,000 feet off the ground. One other thing we tend to look at for these front-end thumps of snow, usually what happens is you have a low going to your west, so you're sending a lot of warm air up and over that cold dome. But in this case, as much of the winter has been, there wasn't much cold air out ahead of this system. So you see on the left, there's the low pressure system coming into Kentucky there. It's going to lift northeast. Again, it's passing to the west of us, so it's going to be advecting warmer air in. That's usually not a setup for a 1, to 2 foot snowstorm or blizzard. But nonetheless, if you have the cold air in place, you could, get say a 5 to 10 inch event. But in this case, on the right, this is the 2-meter temperature anomaly, departure from normal. And notice, first of all, in Canada, temperatures are only a few degrees below normal. So you don't have that Arctic air. And in our area, temperature is actually above normal. So that's not what you normally see for a front end thump. Normally you're below normal and you set the ground for that warm air to come up and over. And that's what really produces the snow. And it also increases your thermal gradient. Remember, we looked at where the best forcing would be. Well, where you have those isotherms tightly packed, those temperature lines, that's where you tend to get your heavy snow. And in this case, we just didn't have that tight thermal gradient because there was no cold air for this time of year. So one of the things you may hear us talking quite a bit about nowadays is the MBM model. And that's something we run, combining all of the weather models together and getting, say, a consensus forecast. Now, the HREF model is more of a higher resolution. The MBM can go out, say, a week, give you an idea of what things might be looking like in the long term. So this is what about 2 days ahead of time things look like. So the 10th percentile actually did fairly well. This is, the lower end threshold. It was basically indicating maybe a coating to 2 inches. Even this was a little bit high, southeast of the Worcester area, but it got you in the ballpark. And then the 90th is kind of a reasonable high end or a reasonable worst case scenario. You can see this was like 2 to 6 inches. That was, say, if temperatures ended up colder than expected. The consensus of the models was basically, a 2 to 4 inch event here. And again, this was too much snow along the coast, and even inland it was too much. So again, it was overdone. One other thing we also look at here, there's a new product we have. It's called DESI, and what it does, it compares different computer simulations, say the GFS, the European, the Canadian, and kind of blends them all together, and you can view them together or separately. But this is where indications were several days in advance for probabilities of over an inch of snow. And you can see they're pretty high northwest of the, Boston to Providence corridor. Even in the corridor, they're indicating that there's a decent probability, a likely probability that you'd see over an inch of snow, and that did not occur. And even the 24-hour probabilities of 3 inches or greater, no one really had this in our county warning area. And you also see here pretty good probabilities of over 3 inches across in interior Massachusetts and into interior Connecticut as well. So it gives you an idea. This is, ensemble guidance. That means we're putting things together, getting out a consensus type of forecast, but it doesn't necessarily mean that's what's going to happen. There are times where could be way too low. There are times where it could be way too high, and there are times it can be right on. In this case, it was just overdone with the amount of snow. And if you look at the 6 inches or greater probabilities, it did give some low probabilities of this. Even that the models were overdone, it still was saying that the odds of over 6 inches of snow in this event were pretty low all along. So again, this never looked like a blockbuster event, but we did expect a few inches of snow and really struggled to get a coating to an inch or so. Another thing we look at are what are called plume diagrams. And what these are, the simulation of, say that this is from the super ensemble model. You can take variations of the models. This is looking at a specific point as opposed to the map guidance where we're looking kind of at the whole, all of southern New England. Now we're looking at specific points. It allows forecasters to kind of dig a bit deeper into an individual site that they're looking at and kind of view the data differently. So There's Euro ensembles in here, there's GFS members, Canadian members, and just to refresh your memory for those who've been on these presentations before, for example, the European model can have over 50 members to it on its ensembles, and basically all you're doing is tweaking the initial condition of the model, and because errors increase exponentially with time, that can make a significant difference. Maybe not 12 hours out, but by the time you get 3-4 days out. So anyway, looking at this Fitchburg, they had about a little over an inch of snow, and you can see most of the members varied from, say, 2 to 7 inches. So again, that's an idea. It was overdone. This is from the Tuesday run, so we're about 3 days out here in the Fitchburg area. Now, if we advance one more frame, this is the next day. So we're 24 hours later. And what you'll notice is that the models are still overdone here, but they did come down a bit. You see a lot more down towards that 1 inch mark. The mean, this black line here, is a little over 2. So again, let me go back one so we can kind of compare that again. You can see the mean was 3 here. And we go back there, it's down to 2. So it was still overdone, but as we got closer in on the event, there was some kind of tendency for the models to start to catch on and realize maybe we don't have the forcing, maybe we don't have the cold air for those higher amounts of snow. And the HREF model, again, going back to that, what we usually like to see for these front-end thumps, because they don't last long normally, you get that warm advection and it's basically a 3 to 5 hour window of precipitation and it's done. You'd like to see those snowfall rates of, say, an inch or more an hour. And you can see the HREF was indicating that initially in Northwest Ohio, and then that kind of tracks into the eastern Great Lakes here. Now notice there's an area down in Pennsylvania, and as you go 5 hours later to 5 p.m. when we're really supposed to get into the meat and potatoes of this event, it kind of breaks up. And that was an indication of that dry air initially eroding that front end of the precipitation. And this is a hourly precipitation type forecast from the HREF. And what you want to focus in on here is where you see the darker shading of snow. That's where you're getting your 1 inch per hour snowfall rates. Now look at here, it's all really light stuff, and then we flip over, and then here comes the heavier stuff in dark green. But by the time that arrives, it's heavy rain, and then kind of switching over to main concern being flooding. So that kind of gives you an idea of what happened. And sometimes the models don't tell you directly what's going to happen. They may be overdone. But I think this was a big clue. You don't see the 1 inch per hour snowfall rates, and you don't see the real dark shadings of the heavier snow. It's all light when it gets into our area. So they do have their ways of kind of letting us know that we may need to make some adjustments. Things are changing. Things may not be ideal. And this was, I think, a good example of that. And if we look at the radar versus the HRRR model, that's one of our high resolution models. You can see this initial precipitation moving in on the HRR. Notice you have these yellows here. It looks, somewhat heavy. But then you look at the radar of what actually happened over this 6 hour time frame. It was nothing, right? It was just very light snow. Look how overdone this model was in the near term. So again, some of the models handled it better than others, but I think in the end, they really did not pick up on that dry air in the mid levels of the atmosphere that really kind of eroded the initial precipitation. And we did get a lot of rainfall once that was overcome. It just knocked out the threat of snow with that front end precipitation falling apart. And these are just different models here. This is the WRF model. Again, they're all somewhat overdone here. This was the ARW model compared to the radar. I think this WRF ARW model handled it a little better than the HRR, but you can still see it's overdone. And then the WRF model, the FV3 WRF model, again, a little better than the HRR, but still overdone when you look at that 6-hour window where we were supposed to get our snow. And again, after that time, the thermal profiles were warm enough to mainly support rain. So one of the other things we really look at is trends in the models. Sometimes it doesn't necessarily mean this is going to happen, but if you're looking at 3 or 4 consecutive model runs in a row and they all start to ramp up, or in this case, ramp down, that's usually a sign that things aren't the model is kind of looking at things differently. Maybe the cold air isn't as deep, maybe the forcing isn't as deep. But if you see that trend happen, like for consecutive model runs, it's probably going to get you in the ballpark if you follow those trends. And if we go to the initial run here, we had, potential 4 to 6 inches of snow in the north central, northwest Mass. And then by the end of it, it was basically barely covering the 2 to 4 inch range. And that was for the far areas like near the New Hampshire border and into the Berks. And honestly, that was even overdone. So a lot of moving parts with this, but you had the better forcing again going to our west, I should say. And you also had that lack of thermal gradient, which I think played a role because you did not have a normal, very cold air mass that is often in place when we're talking about late January in southern New England. So to kind of look at that in a different way, we looked at it on the HREF, some of those models. But this is looking at the meso analysis that we have access to. It's actually off the Storm Prediction Center site. It's used a lot for severe weather, but it can also be helpful for winter weather. And you can see in the shortwave energy, which is just lifts, say, in the upper levels of the atmosphere, we're about 20,000 feet here, is to the west of southern New England, and it's actually lifting to our west and north. So there is some lift here, there is some shortwave energy, but you can see the bulk of it is where you have these yellow and green colors here. It's much more sparse. This is at 4 p.m. Again, so we're right in that 1 to 7 p.m. window Wednesday afternoon when we were supposed to get that burst of accumulating snow. And another way to look at it, the 700 and 850 millibar frontogenesis. Again, we're accustomed, to looking at, say, temperature gradients at the surface where it impacts us, but a lot of times, rain or snow production is controlled by that forcing 5, 10, 15,000 feet above our heads. And a common theme here at 5 o'clock that afternoon, notice the best forcing is just to our west. That's where we saw the 1 inch per hour snowfall rate probabilities from the HREF model. Again, we're just weaker lift here, and then we're contending with that dry air. And temperatures, the air mass, again, it was cold, cold enough to initially support snow. But it wasn't, a situation where we had like a typical very cold to Arctic air mass and we were going to overrun that. Because the more that thermal gradient it tightens, the atmosphere has to respond to that to try to balance things out, and that's where you get that stronger lift, heavier precipitation. It's because the atmosphere is trying to get back into balance, and we just didn't have that thermal gradient. And actually, by lunchtime, temperatures were basically above freezing across much of the region. So we had an initial band of light snow or flurries, wasn't going to accumulate. And by the time the next round came in, temperatures were above freezing. So as light as it wasn't really going to even accumulate on non-paved surfaces with those temperatures. in that range. And then, we started to get, increasing southeast flow, as that main low was headed west of us, and, just warm advection, wind off the ocean. That's definitely not ideal for, a big snow event in southern New England. We did have some wind, as I mentioned. Nothing too crazy, but we had, 35 to 45 mile an hour gusts, which is typical, whether you have a low going to your west on the, I-95 corridor, a few in the 45 to 50 mile per hour range as well. Nothing too extreme for that time of year, but, whenever you get a decent system like that, that can be expected. And here's another way of looking at it. You can see, you tend to get a burst of wind on the I-95 corridor. It usually tends to be somewhat weaker in the interior, and then you get another burst, usually in the Berkshires and higher terrain areas. But it can differ from event to event. But in this case, nothing too out of the ordinary here. Another thing we tend to look at, in the NBM, there's a lot of parameters on this national blend of models. Looking at, say, the probability of 34 knots or higher winds over the ocean. So you can see it's all highlighted here. That's our threshold for gale headlines, which we have a big marine community. A lot of fishermen and fishing vessels out there this time of year. So it's important we let those folks know. We still have obviously ferry service from Nantucket to the Cape to the Vineyard. So those folks need to know what the winds are, and our advisory criteria, usually 40 knots or higher. So this was the probabilities of those thresholds, and you can see we were right at advisory thresholds, like down towards the Cape Cod Canal, in that area. Just most of the area was below, and you can see the probabilities of that were below. So again, the wind forecast was handled well by the models. It was mainly the snow on the front end of the system, and you can see this was the 30-hour wind gust forecast valid at 1 a.m. Thursday, and you can see forecasting those higher winds down along the south coast, Cape and Islands, and again that area is climatologically favored, and these are actually these are winds in knots. So 40 knots would be like 46 miles per hour. Wind gust 43 knots would be like 48, 49. So again, there was a narrow area where we did hit that wind advisory criteria. It was right in this area. So again, good job by the guides in respect to that. And again, this was like a 18-hour wind forecast, so not too much had changed there. Again, so to summarize, snowfall forecasts were overdone for this event, especially across the interior. Again, this is the northern and northwest, the east slopes, the Berks here. There were some 2-inch reports, but most areas outside of that were just basically a coating to an inch. Again, the front end thump did not materialize. I think the focus was west of New England, where better 700 to 850 dynamics were. You had better wind speeds, better thermal gradient at those levels. Temperatures were above freezing by the time the precipitation came into play, and we didn't have an Arctic air mass to overrun, which made the thermal gradients weaker. So instead of forecasting a few inches of snow, the main concern was rainfall and flooding, and we did have some minor river flooding, and we actually had flood watches out for that. So that was handled well. It was mainly, and we did have wind advisories down along the immediate south coast, which was also handled well. But the only issue again was the snowfall forecast. We were just overdone with it, and we always take that as an opportunity to learn and improve. When forecasts don't work out, are often the best times for that. So with that, I'm going to see if we have any questions here. And it doesn't seem like I see any right now. And if you do have any come up, you can certainly email myself. It's just hayden.frank@noaa.gov. And we do have some time, and I wanted to give a brief map overview here, or map discussion of what we're going to be looking at here over, say, the next week or two. I know that's always an interest for people. So let me call up some few things here. Just bear with me here. So we'll start off with the HREF model and kind of take a look at what we're looking at here, give a little simulation. So this is today's run of the HREF model. Obviously a very warm day, especially across Connecticut, Rhode Island, and Southeast Mass with temperatures pushing 70. Now this is as we get to 7 o'clock here. So this is pretty much on target. We have a band of showers moving through this evening, and looks like we may have a little break in the action here. So this is an initial burst of warm convection, and as we go along here, you can see a shield of heavier rain organizing to our west. This is 12Z tomorrow, so this is Friday morning. There's a few showers in our area, but you can see the heavier showers, and actually the models are actually putting out a potential for thunderstorms with this too to our west. It's not out of the question that one or two sneak into our area too, although the better chance probably to our west, and then this moves through in the morning through, I think, early to mid-afternoon. May see some heavy rain. Temperatures are going to be quite mild out ahead of this. And if we switch here to the 2-meter temps, here's the warmth of today, and you can see with this low going to our west again, southwest flow, and temperatures, tomorrow out ahead of this, probably upper 50s, low 60s, even with the rain. And then as this low goes by, this is 20Z. So again, if you're 18Z, it's roughly 1 o'clock. So if you think of 18Z, pretty much on the UK time there. So if you're computing it from military time, it'd be 5 hours earlier our time. So 18Z is like 1 p.m. Eastern time. And you can see there's the low, and here comes the front moving through. And behind the front, it gets noticeably cooler. Temperatures by 0Z. A lot of the area down into the 30s to near 40, and even some 20s out there. So after the first part of the day is going to be pretty warm. Things will cool down pretty quick, and kind of blustery, and temperatures by Friday night's going to feel pretty chilly compared to the last couple days. Temperatures down into the teens and 20s. So quite the change there. But I wanted to take a look a little bit further out here, what to expect in, say, as we close out February here and go into early March. So this is the 8 to 14 day outlook, and quite the change from what we've experienced. Even if we were just near normal, you can see there's the tendency for some colder air, especially out west, where it's been more common this year. But also a tendency in northern New England with above to well above normal temperatures hanging tough in the southeast. So there's going to be some more opportunities for cold in our area, but there's going to also be a large gradient, and we're probably going to be in the midst of that, which means we may have some cold waves, we may have some overrunning wintry precipitation. Obviously, it's too early to say for sure, but I think as we go into early March, there are going to be a little more opportunity than what we've seen. So I'm going to take us through the GFS model here. I just want to focus on one model, kind of get a handle on how we would go about, putting together a long range forecast. And again, this is the GEFs. And when I say GEFs, it has individual 20 GFS models with their initial conditions slightly tweaked. And again, you can get significantly different outcomes as you go out in range, because errors can become exponential over time as they add up. So this is basically where we were this morning. You've got, and again, we're at 20,000 feet, so we're looking way up in the atmosphere here, and you'll notice there's a ridging off the southeast coast. And where you see these reds here, that's above normal heights. That's usually going to indicate above normal temperatures. So you'll see this is not a surprise. We set record highs today based on this. So let's go through here, and we're going to get to tomorrow morning. And here comes this brief troughiness that's going to come through. So that's a brief return to seasonable cold. But look what's to the right, to the west of us. So Saturday, we have highs in the, say, upper 30s, low 40s, which is seasonable. Look what's coming. We're warming right back up for the close of the weekend. And this is going to be Sunday, Monday, we're getting into. But notice here, you're getting the tendency for more cold air, these lower height fields, as we call them, to come into play. And this upper level ridge that was kind of more potent early on is starting to get a bit suppressed. But it will make a recovery here as we go. So we're basically Tuesday 0Z now. And as I go forward here, you'll see it try to pump up again as you get really low heights out west. Some pretty unsettled weather and some cold weather out there. But look at our heights again. This is right back at us. This is Thursday 12Z. So that's an indication of another round of above to well above normal temperatures. Wouldn't be surprised if we take a run back into the 60s even, as long as we're north of a low pressure system. But I think after this, as we get towards next weekend, you'll start to see better suppression here with this. And I think this time it may last a bit longer. And we're going through, this is a week from Wednesday, so we're 312 hours out. And right into the end here. Again, this is just one model. It's not screaming cold and snow, and we may even be mild at times. But I think you'll see that there's a tendency for colder air to be setting up into our north, and that may come into play at times as we kind of go through here. You can really see there are lower heights nearby. This ridge that's been plaguing us with abnormally warm weather all winter is tending to get somewhat more suppressed. So I wouldn't really look at any big winter weather threats through, say, next Thursday. Once we get beyond there, a week from Friday into the following week, perhaps. It's not a guarantee. There may be some opportunities, but we'll just have to wait and see. This is another way of looking at it. We're at the surface here. So what you'll see here, the low, the big low, this is the operational run here, and then these other little smaller lows that you see kind of splotted there, those are the ensemble from the models. And what you'll see is as we go further out in time, you'll see the spread of those get larger because errors become exponential over time. And you'll see there's more uncertainty in the model. So this is tomorrow. There's the low. There's the front goes by. We get colder. High pressure moves in. This is Saturday night. Saturday night could be a chilly night, good radiational cooling before we start to really warm up. Take a run back at 50 maybe by Sunday. You got a low coming out to the west here, so you're getting more of a southwest flow. And then you may get a little brief cool down here. But as we talked about towards the latter half of next week, maybe looking at a low pressure tracking again to our west. You can see it there. And if that happens, we could be pretty mild again for a day or two. And then I think there's going to be more opportunity. You see this high pressure builds in with some colder air. Again, it's harder to see in the ensembles, but if we have a few weak waves kind of trying to overrun that, that could produce the threat for a little wintry precip. You kind of see one approaching here. Again, we're looking at ensembles and you're looking at them way out, so you don't necessarily see the big lows. In reality, they could be a bit stronger than what you see here, but there's something passing underneath us there. You can see it going by. Another high builds in. There's another low offshore. So again, it's something I think once we get to next week, we'll late next week, Friday, beyond that, I think that's when we may have a shot here. And here's the Jeff's temperatures. So this is, again, Thursday morning. So that was this morning, I should say. Here's the warmth of this afternoon. And we're going into tomorrow morning. Look at that, a very warm start. Temperatures probably in the upper 40s to mid 50s at daybreak here. And then, may break 60 again in a lot of places this Friday 18Z. Here comes the cold air rushing in. Saturday, a chilly day, nothing crazy. And as we go into Sunday, temperatures pushing 50 by afternoon. Monday, back into the 50s. You can see 18Z 54. And sometimes these are what we call 2-meter temps. During the afternoon with sunlight, they could actually be a couple degrees too cool. So it's going to be mild again into next week. We get a little front go by later Monday, bring some cooler air in, but nothing too cold. Temperatures probably still above normal. Wednesday, you can start to see the warmth creep up from the south. And this is in response to that low trying to come to our west, depending on how that does it. Now, what you see here, what's interesting on the GFS ensembles, it struggles to really get the warmth in here on Friday. So other guidance takes it further north. But behind that, whatever happens, whether we get really mild Thursday or Friday of next week, it looks I probably more towards Thursday. Colder air is going to be lurking to the north. And you can see as we go along here, I'll say beyond, say, 200 hours, there's a lot of cold air across the north states. It's still quite mild across the southeast, but we're going to be subject to that as a potential overrunning warm air coming up and over a potentially cold dome at the surface. So I think that's why there is going to be a greater threat of wintry precipitation once we get beyond Thursday of next week. But again, nothing set in stone this far out. And this is a look at the 2-meter temperature anomalies. We'll take a look at one more thing, and then we'll wrap this up. So what this indicates, you can see, the medians in the shading, and then you can see these numbers here are how much above normal. Like one will be the lower end, one will be the higher end. So you can see if we go to today, right at 18Z here, temperatures, running 20, 25 above normal, even higher than that. And as we go into Friday morning, you can see here temperatures in some instances 30 degrees above normal, given the expected temperatures at daybreak out ahead of that front. And then we cool down. You can see a little bit briefly even below normal for a time, maybe Saturday morning. But we warm back up as we go into Sunday, Monday. We have a little cool down to the north Tuesday. And then, depending on how far north this warm gets, you can see that warm air trying to get up there on Thursday, perhaps into our area before we really cool down. And then once again, from Friday of next week into the weekend and into the first days of March, you can see there's a tendency for temperatures to be running below normal. So again, looks like some type of pattern change going on in the end of next week into the first week in March. But again, we'll have to see how things unfold. It's still a long ways off. So with that, I'd like to thank everyone for joining us. Again, please feel free to submit any questions to us. Again, you can email joseph.delacarpini@noaa.gov or myself, hayden.frank@noaa.gov. I'd be happy to answer your questions. And we like doing these. And we do have, again, our next planned webinar is going to be a remembrance of the superstorm of 93, the March 12th and 13th storm of 1993 that really pounded a lot of the eastern United States. So with that, again, big thank you from all of us at the National Weather Service, Boston Norton. Really appreciate you being with us tonight. And we will talk to everyone soon. Thank you so much.